All right, how's it going? So, yeah, this is going to be showing you how to make a nut and bolt in Inventor, and I'm going to show you how to do it with the thread tool. So this is what we're going to be creating, a nut and bolt assembly, where it will actually, at the end, it will rotate. Yeah, cool. So what you're going to do, you're going to start, you have to make them as separate. So we're going to make a new part, standard part. We're actually gonna switch this guy into metric. So we're gonna do a standard millimeter. Great, cool. So we're gonna wait for this to load. So now we're gonna start with a 2D sketch. You're gonna select the XZ plane. You're going to go down to the rectangle and you're gonna select polygon. We're gonna make it a 6-sided polygon. Go here. And right now we're making the actual bolt. Go here, done, dimension. We want this to be 19 millimeters. Okay, finish that sketch. Now you're gonna extrude this. We want this to be 7 millimeters. Okay, oh shoot, sorry. We want this to be 7.5 millimeters. Okay. Now we're going to actually do a new sketch on top of that. We're going to make the circle on top. The point of the circle, and it should be exactly 19 millimeters as well. Point of the circle is actually going to be later, but it's also going to be to make the head of the bolt. So what you're going to do, you're going to go into extrude. You're going to extrude that. You're going to click intersect. You're going to make it through all. And you're going to make this 45 degrees. And you're going to click OK. Look. You have the head of a bolt. Now, do a new sketch on the base of it. And I'm going to make a circle. It's going to be 9 millimeters, which is the standard width of this size of bolt. Finish that sketch and extrude it. And it is going to be a 20 millimeter long bolt, or sorry, 40 millimeter long bolt. Cool. So now what we're going to do, and this is where the thread tool comes in. So there's a lot of settings in this thread tool, so be aware of that, that are all very different depending on the kind of threads that you're trying to make. So you're going to click on the thread tool. Select surface, you're going to select that surface. So right now it automated to a size 9 with a M19 by 1.25 in a 6G class, which we definitely can do. You can do whatever you want here. I mean, it's all dependent on the bolt that you're trying to do. The reason that this autofilled is because this is the kind of bolt that I'm trying to design. So we're going to click OK. Now, just to make this a little bit prettier, and it'll look a little bit more like a bolt, what we're going to do is we're going to come up here. We're going to go to chamfer, select that, make that 1 millimeter. Right now it's got that like more nicer end. Then we're going to fill it, select right in there. We're going to make that 1 millimeter as well. Cool. So it shows you it's really not that hard, but now I'm going to show you how to do it as a nut as well. So I'm actually going to call this nut. Sorry, bolt. I'm stupid. Bolt 3. All right. Now we are going to save that. And I'm going to go home. New. And another standard metric part. Start a 2D sketch. And you're literally going to start this exactly the same as the other one, except for the fact that instead of having it straight up and down, I like to go sideways for this. It really doesn't matter though. Now you're going to done. Dimension here and here. Again, 19 millimeters. Finish the sketch. Come in here, extrude. We want this to be 7.5. And now here's where stuff starts to differ. So again, come up here. We're going to put that circle right on top. We're going to extrude it through all, intersect at 45 degrees. This is a good tool to know how to use or know how to do this. Now what we're going to do is we're actually, because we're making a nut now, we're going to mirror that on the bottom. Boom. Extrude. Cool. All right. So now we have that. So now you need to remember, right? This 9 millimeters. This, we're going to put a circle in the middle of it. So we're going to come onto here, new sketch. This circle is going to be 9.125 millimeters. The reason for that is because if it was perfectly the exact same size, it would not work very well, right? Because that's not how tolerances work. But that's a very that's a pretty tight tolerance, especially when we're talking like 0.125. That's 0.125 millimeters. Like, that is a super tight tolerance. About what you want with threads. Cool. So now we're going to come into here. We're going to extrude that through all. Cool. So now we've created this hole. Now what we're going to do is we're going to use the thread tool yet again. We're going to select this inner surface. So you notice it's actually different. So we want to you want to make sure it's the same. So it auto-filled to the same that time when I selected a size 9. But you want to make sure that your threads are the same, because otherwise, in theory, if you were like 3D printing these parts, this nut and bolt would not work together because the thread depths would be different. So you're going to click OK. And then now we're going to chamfer at 1 millimeter there and on the other side, and select OK. Nice and aesthetic. All right, cool. I'm going to name this nut 3 because I have 3 different nuts and bolts. Oh, not all in caps though. Nut 3. Cool. Save. Okay. So we're gonna go home. New. And this time we're gonna do a standard assembly. Okay. You're gonna click place. You're gonna find that bolt, not the nut. We're gonna start with the bolt. Open it. Right click. Place grounded at origin. And press escape because you already have the bolt that you want. Now you're going to go place. You're going to find nut 3 or whatever you've named it. Make sure you name it something that you know so you can find it. We're just going to place that right there. Cool. Now we're going to click constrain. Come into here. We're going to constrain these. You're going to come over here. You're going to press. You're going to open down both the drop downs for the bolt and the nut, drop down the origin, and you want to constrain the y-axis to the other y-axis. Did you hear it? So you can click OK. And so now you'll see you can actually, that nut is going to be bound along that y-axis, or mated along the y-axis for both of them. So you can collapse those, you're not going to need that. There you go, constrain. And now we want to square it up with this end. So what we're going to do, we're going to go to a flush constraint. You're going to select that, and apply. And now we're going to do one more. Just going to be an angular constraint, a directed angle. We're going to select that, and apply. Cool. So those last two constraints were actually just to square the whole thing up. So you're going to now have to go back over to relationships. You're going to hold control, or you can do them individually, and you're going to select the flush and the angle. You're going to right click and you're going to suppress both of those, because otherwise your rotating won't actually work. And you can actually see the tolerance here. You can see that super narrow little line. Cool. Now you're going to go over into environments and you're going to click dynamic simulation. You're going to insert a joint. We want that joint to be a screw joint. Now what you're going to do is you have to select the round part. So this is where that making that circle, making the heads of these the nut and bolt is really important. So you're actually going to select this little curve here. You're going to come around, you're going to click component 2, and you're going to select this little curve there. And we want this pitch to be 1.7. Okay, apply. All right, now you can close that. There, you come over here, see where it says standard joint, click that drop down, right click on the cylindrical, go to properties. You're going to go to this one, the DOF1R. And we're going to select edit imposed motion. Now you're going to enable imposed motion, select velocity, which is already selected. You go over here and it's going to go constant value. Now this constant value is going to be like how many degrees you want it to move per second, right? So it's 360 degrees. And then because this is 40 millimeters long, you can do the math. It's going to be about 18. And you're going to click OK. And now you just click play. And boom. And you can like drag this back and forth and stuff if you want. But yeah, that is how you do it with the thread tool.